25 miles an hour in 3 seconds.
We are standing on the flight deck of the USS Dwight D Eisenhower.
Planes taking off and landing are just the tip of the iceberg.
There are over 3,000 sailors that have to make this all work, all with important jobs in it.
It also takes a lot of math and a lot of science.
Today we're going to take a look at what it takes to land and launch planes off the Eisenhower. This is STEM in 30.
This
Is STEM in 30. Hi, I'm Beth.
And I'm Marty.
And we are coming to you live from the Stephen F. Udvar-Hazy Center in Chantilly, Virginia.
Today we are starting at the end of an F-14 Tomcat. For years, this was the predominant fighter jet used by the United States Navy.
Before we begin, we want to welcome our in-house audience today, St. Timothy's Catholic School. Now, when you noticed our opening, Marty and I were talking to each other, but we really couldn't hear each other, so we had to use a lot of hand signals.
An F-18 at full power is really loud, and we were really close.
Now, it was hard for us, but we did practice the script using only our hand signals, not speaking to each other. Because when you are on the deck of the carrier, you really can't hear, so everyone is using hand signals.
As I mentioned before, we're standing behind an F-14 Tomcat. This is the tailhook.
This tailhook allows the Navy planes to land on the aircraft carrier deck.
Think about the amount of stress on this tailhook as this Tomcat came in for a landing.
We were fortunate enough to visit the USS Dwight D Eisenhower, which is a nuclear-powered aircraft carrier.
We got a chance to see flight operations up close and talk to the women and men who take great pride in the hundreds of jobs they do on board.
Let's take a look at Ike.
Hi, I'm Captain Paul Spadero, the commanding officer of the USS Dwight D Eisenhower. Ike is a Nimitz-class supercarrier that provides a wide range of flexible mission capabilities to include maritime security operations, forward naval presence, and humanitarian aid on behalf of the United States Navy. The ship's embarked air wing is capable of projecting tactical air power over the sea and inland, as well as providing sea-based air defense capabilities. It's easy to see that pilots play a big role in what we do, but there are thousands of other sailors on board that do hundreds of different jobs to support all of our goals. On board we have cooks, dentists, mechanics, journalists, air traffic controllers, lawyers, doctors, firefighters, ministers, and even teachers. It's a small city at sea, and the young women and men on the crew come from all different walks of life and take pride in the role they play on board the mighty Ike.
And now I'm joined by Chris Brown, who's the Deputy Director of the National Air and Space Museum. Chris, thanks so much for being here today.
Thank you, Beth. It's great to be here and to join with the school, St. Timothy students.
Now, Chris, before you started at the museum, you did have another career that was in the Navy. Do you want to tell us a little bit about that?
Yeah, I actually did. You got to rewind to 1980 when I graduated from college. I wanted to fly airplanes, and no better place to do it than with the U.S. Navy. So I joined the U.S. Navy and went on to train and then fly F-14s like the one right behind me as a flight officer or radar intercept officer, the person in the back seat of the F-14. I did that for 7 years, made a number of deployments, and then did 13 years of reserve flying.
And you have a special connection actually with this plane behind us.
Actually, yes, there's a very close connection to this. As you know, there are lots of F-14s, but when this one was introduced into the collection back in 2006, I thought, well, I wonder, what are the chances that maybe at one time I had actually flown this exact aircraft? So I checked my logbook where we recorded every flight ever taken and by aircraft number, and sure enough, in the late 80s, I had the occasion to actually fly this very airplane.
Now, you were a RIO, What is a RIO and what did you do?
Well, we say, as I mentioned, RIO stands for Radar Intercept Officer. The F-14 was designed and built around the weapons system. And so the person in back, the RIO, manages the radar, the weapon systems, all the ordnance, communications, navigations, everything that really makes this aircraft the air superiority fighter that it was.
Now, the planes and the pilots are just the tip of the iceberg. There's a whole crew that has to do their jobs to make you able to fly. So do you want to talk a little bit about that?
Sure. You know, as aircrew, we had the incredible privilege to be able to take this kind of aircraft and actually fly off the deck of the carrier and conduct flight missions. Very, very cool. But the airplane doesn't move an inch unless it's been properly maintained and fueled. The handlers on the flight deck that guide us around the flight deck, the people that work and maintain and operate the catapult, the arresting gear, the cooks that serve the meals to all the sailors. And as you saw from the captain on the Ike, as he described, everybody has an essential role. And the thousands of sailors and airmen on the Ike play a critical role, and every one of them can see how the job they do actually connects to getting this aircraft off the pointy end of the ship so that it can do its mission successfully.
Now, we spent a couple of days on Ike, and we did a lot of walking. And while we were walking around, we were able to talk to the crew, and we're going to show you some of the jobs that you might not have thought about.
On deck during flight operations, it looks like chaos. One plane's coming in, one plane's taking off a few seconds later.
But it is very precisely choreographed, and the men and women who work up here rely on the people below to take care of them.
Let's go inside and check out some of those other jobs you may not have thought of.
Now, Chris, Marty and I did have to fly onto the carrier and off the carrier, but we were in the back and not in the cockpit. So how do you land a very fast plane on a boat?
Carefully, because, you know, from the altitude looking down at the ship, we used to say it's like a postage stamp, but it's actually 1,000 feet long. It's it's the largest ship on the afloat. But the landing space is, as they say, maybe 700 feet, but in order to land the aircraft successfully, you've got to touch down in a space of just several hundred feet to catch one of 4 cables. If you miss those cables, you got to go full power when you land so that you have enough energy and airspeed to take back off and try it again. So everything is about trying to figure out where you are in that piece of sky, that what you have to do is to get on this part of the deck, and oh, by the way, this ship is moving at the same time. And it's also rocking at the same time. So a lot of things have to go into doing it successfully, but we get a lot of help.
And that sounds a little bit complicated, but I think Marty is going to help us figure out how to do just this with math.
Yeah, so we're going to talk about the math with this, and we're going to talk about coordinates, and I'm going to use a plane to do that, so that means we're talking about coordinate planes. Get it? Math joke? Again, nothing. All right, so one of the neat things about this is that this is real-world math, or a real-world application of something that kids learn in middle school. So what you're learning really has a real-world application. So I want you to imagine that we have a coordinate plane here. Actually, let's actually put the coordinate plane here. Let's do that. Coordinate plane. All right. I'm going to move my airplane back up here to our starting spot. So I've moved the plane back 15 feet and up 8 feet. So we're at 15.8 on our coordinate plane. That's our starting spot. We're going to go over and land on the deck of the aircraft carrier. Now you might be thinking, why aren't we landing at 0, 0? Don't forget, the deck of an aircraft carrier is about 50 feet up off of the ocean floor, or off the ocean. So for our simulation, we've got our aircraft carrier deck about 3 foot up off the ground, so our coordinates over there are 0, 3. Now we're going to calculate the slope using those coordinates. So the first thing we need is our formula. So boom, there's our formula. We've got our second y coordinate, and we subtract our first y coordinate from that. We do the same thing with our x coordinates, and we fill in the numbers, and boom, we've got our numbers, 8 minus 3 over 15 minus 0. We need to do a little bit of math with that. We do the subtraction, and boom, there we have 5 over 15. Now I know all of your teachers will tell you we can't use 5 over 15 because that fraction is not simplified. So when we look at that fraction, I think what goes into both the numerator and the denominator? 5 goes into both. So we do a little math there, and boom, we end up with 1 over 3 as our glide slope, or as our slope here. That tells us something. That tells us that for every 1 foot we go down, we move over 3 feet. And the really cool part is that no matter where on this slope we want to know, we can figure it out if we know the slope of that line. Chris, how'd I do?
Really well. Very, very good. It's very technical, but I will tell you that when we go to flight school, that's what you start with. Because you got to understand that part before you can begin to use instruments and other aids in the cockpit and other technologies. And guess what? Sometimes technologies fail, and so in order for you to have the situational awareness and understand these things, it really starts really right where you are today with some basic math.
But let's see if you can actually land it, Marty.
All right, now before we land it, I do want to point out that we've exaggerated the glide slope a little bit. The actual glide slope for an aircraft carrier is 3.5 degrees, which is going to be way down here. This one's a little bit more, but let's see if we can land it here. All right, on the count of 3. 1, 2, 3.
F-18, call the ball. Roger ball. Okay, 3-wire. I wish it were that easy. That's a great demonstration.
Now, as we said, it takes a lot more than just a pilot to land, and we actually were able to talk to some of the sailors about the jobs, the important jobs that they do on board Ike.
My name is Ian F. Fowler. I'm from Bessemer, Alabama. I work in Reactor Auxiliary. We supply power.
I'm ABH3 Fisher. I work in crash and salvage on the flight deck. That's flight deck firefighting.
My name is ABH3 Parrish. I'm from Newburgh, Oregon. My job on the carrier is to secure planes to the deck.
My name's ABH304 Yada. I'm from Bridgeton, New Jersey. I work in primary flight control.
My name is Seaman Alyssa Bedell. I am from Ocala, Florida, and I drive the Uss Dwight D Eisenhower.
My name is Clinton Neal Stormont. I'm from White Springs, Florida. What I do here on the ship is I direct aircraft while they're in the hangar bay.
Hello, I'm Airman Buendia. I'm from Miami, Florida, and I'm a aircraft handler.
I'm Nathan Beard. I'm from Green Bay, Wisconsin. I work on Ike Media.
Hi, I'm Lieutenant Jennifer Roberts. I'm the OI Division Officer on board here, and I'm from Virginia Beach, Virginia.
I like it at night. I like night ops. You see a lot of stars, especially when we were overseas.
I really like the aviation part of the Navy. Quite amazing to watch the planes take off and land on such a small area.
View of the stars you get at night, being out in the middle of the ocean, it's the best view of the stars you can get.
I've been able to see all types of places in the world, and it's just been a fantastic ride the entire time.
Well, I get to go different places, meet new people.
The importance of teamwork is essentially one of the most important things on board the USS Dwight D Eisenhower.
Yeah, working as a team does make everything function well and keeps the ship running smoothly.
You have to be able to work together and not conflict with each other.
It's a big family team. You have the CSs who are cooking to nourish everyone. You have the deck seamen who are driving the ship to get us to where we need for the mission. You have the ICs who are making sure all of our equipment is working properly so we maintain safety at all times. So it is a big team effort throughout the Dwight D Eisenhower, and all the rates are essential for this mission to be done.
I decided to join the Navy for a good education.
My father, he's actually still in the Navy.
I take pictures, I document history in the making.
The pilots expect us if something goes wrong to save their lives.
Follow your aspirations.
Try everything that you can.
Being on the Ike is greater each day.
Chris, are you ready for some questions?
Absolutely.
Okay, we've got an audience question first.
Hi, my name is Nicholas Gura. My question is, how do the planes know where the aircraft carriers are?
How do we know where the aircraft carriers are? That's a very good question. That's kind of important, right? Well, before every mission, we have what's called a pre-brief, where we gather in what was called the ready room, and we brief the entire mission before we even put on our flight equipment. And part of that is, where is the ship at this moment? When we launch that aircraft, where is it? Because we might not know sitting back in our ready room. So we need to know where the ship is located, its coordinates, when we take off. And then we need to know where is it going to be in 2 hours when we come back to land. So we have that figured out, but sometimes maybe there's weather and the ship isn't exactly where they said they were going to be. So how do you find it? Part of it goes back to dead reckoning, having a sense in terms of where have you been, how far did you fly, in what directions. But we have some great aids, navigational aids on the aircraft that help assist us, things like GPS. I know that you know what GPS, it's on your phones. Things like that help us identify the location of the carrier. We can also do it covertly. And part of that is with the help of an aircraft called the E2C. It has a big frisbee on top, and it's an airborne controller.
All right, we've got an online question next. How long can an aircraft carrier stay out to sea without restocking supplies?
That is a great question. So how do I say this quickly? The carrier battle group, which is its carrier and the accompanying ships, can stay at sea indefinitely. First thing, nuclear-powered carrier, it doesn't have to get refueled for over 20 years, okay? So now you can stay at sea a long time. How do we get things like fuel and provisions on board? Other ships come up close and transfer supplies onto us, and then also come by helicopter. It's called underway replenishment, and there's no Navy on the planet that does underway replenishment as well or as extensively as the U.S. Navy. So the answer is, these carrier groups can stay at sea indefinitely.
We have an audience question.
Hi, I'm Janelle, and I was wondering where they sleep on the ship.
Okay, now where do they sleep on the ship? We actually took a look at where they slept on the ship. One of us had an easier time than the other. We're going to take a look at how enlisted sailors live when they're on board the aircraft carrier.
They're down here. Come on.
I bet your bedrooms are bigger than that.
We have another audience question.
Hi, my name is Yoon, and what is it like to be on an aircraft carrier?
What is it like to be on an aircraft carrier?
I can tell you, we spent 3 days on board, 2 nights, and it's not like living at your house, I guarantee that.
Yeah, it's a lot different. It's a lot different.
And there's a lot of training that goes involved with that, that's involved. The crew is constantly training. At one point, we went up to Vulture's Row to look down over flight ops, and there's always a helicopter that's out when planes are taking off or landing. And I look over, and here's this helicopter just kind of hovering there, and for a minute, I really felt like I was inside a video game.
One of my favorite times on the ship was when we went out to watch night ops, which is training at night. You have to be able to take off and land even at night. And as we were out getting ready for night ops to start, the sun was just going down and the International Space Station just went right overhead. So that was really neat to see.
Did you have a favorite part of being on Ike? You spent a lot of time on there.
I had a favorite and a less favorite, and I will say that the night landings could get pretty hairy. Because remember, like I was saying before, the ship's moving, it's rocking, it's pitching, a dark, dark night. Yeah, that's why you do a lot of training. But my favorite time was actually when we would get up to the catapult and you're getting ready to go. You got all this energy ready to release on that catapult, and everybody's working to make that happen. As aircrew, we had the privilege of being in the aircraft, and you get literally shot off the front end of the deck, and you're off flying, and the flights were magic.
We got to see some of those takeoffs right up close, but we also felt them everywhere on the ship. No matter where you were on the ship, you knew when a plane had taken off because the whole ship would just shudder a little bit and you'd hear this kind of thump sound. And that was the catapult hitting the water break under the deck.
Now, there is a lot of math and a lot of science that goes to catapulting a plane off of a ship. And we got a chance to hear exactly how they do that.
Here we have a mock-up of our catapult launch system. What you see here is a replica of a nose landing gear of an F-18 Hornet. This is the toe link fitting, the launch bar that fits into the shuttle of the catapult. And this represents the flight deck of the aircraft carriers. Below the flight deck are 2 steam pistons and 2 large cylinders. When that catapult fires, steam is ported into those 2 cylinders, and the airplane is literally slung while attached to this launch bar 310 feet to go from 0 miles an hour to upwards of 160 miles an hour to achieve the airspeed it needs to maintain safe flight. Unlike the act of landing aboard an aircraft carrier, which requires a tremendous amount of concentration as the pilot is managing a host of variables, a catapult shot, the pilot and the aircrew are pretty much along for the ride. You're hoping that everything works. You go to full power on your engines. You do one final control sweep and check of the rudder pedals to make sure all that your flight control surfaces work. You give a snappy salute to the catapult officer. You put your head back and you wait for what is a tremendous jolt as that catapult fires and accelerates you from 0 miles an hour to over 150 miles an hour in about 310 feet. It is a tremendous acceleration, and when that shuttle, that catapult hits the end of the stroke and that shuttle hits the water break, the deceleration and that jolt, and now you look up and you're flying.
Ready for some more questions?
Absolutely.
Got another audience question?
My name's Brandon, and how long does it take to get the jet ready to take off?
Wow, another great question. It can actually take a long time because there's a lot of work that goes into it. You have to fuel the aircraft, make sure the engines are all properly maintained and everything like that. But once those things are all done, we can be ready to launch within less than 5 minutes notice. There were occasions where we did what's called the Alert 5, which is the aircraft are sitting on the catapult, we're in the cockpit, our gear is on, all we're doing is waiting for the call. And when the air boss says, launch the F-14s, we have less than 5 minutes to start up the engines, get everything going, catapult's ready, and we're airborne in less than 5 minutes. That's called the Alert 5, and there's a lot of work behind the scenes that's got to go into making that happen.
Got another audience question.
Hi, I'm Claire. How long is the runway on the ship?
Not long enough. As mentioned, the ship's 1,000 feet, just over 1,000 feet, and then the area that you have to land the aircraft, while it's 700 feet, the area that has the cables that you need in order to come to a stop is it's about 300 feet. So from up above, it looks really small, and how we figure out to get from way up there right to down here, that's the challenge.
Well, at the end of our time, we were catapulted off the front of the ship, and it moves pretty quickly. Let's take a look.
I've gotten picked on just a little bit from that video. I do not possess the ability to not scream while that's going on, and apparently lost all function of my facial muscles while we were being launched.
You are so lucky that we are out of time because I would make fun of you some more. Thank you, Chris, so much for joining us today.
Oh, thank you, Beth. Thank you, Marty. And thank you, St. Timothy's, for joining us at STEM in 30.
And we also want to thank our sponsor, the Gertrude E. Skelly Charitable Foundation, and of course, the Department of Defense.
We want to thank everyone who has served in the United States military, and especially the men and women on board the USS Dwight D Eisenhower. You guys are incredible.
And today we are going to end with our friends from the USS Dwight D Eisenhower.
Thanks for watching.
Thanks for watching.
We have spent the last 2 days on board the USS Dwight D Eisenhower, and the thing that jumps out at you as you walk around is the youth and diversity of this amazing crew.
I'm an aviation boatswain's mate fuelie, so I deal with the fuel and getting it up to the fuel to the jets here.
I work on the ship's weapon system. Operating and maintenance on the weapon system, we got to make sure all our gear is good to go, make sure everything's within reasonable tolerances of how it's supposed to work. Make sure signals are flowing properly through all of our equipment, make sure all the equipment communicate with each other, and also communicate with other systems to make sure everything runs smoothly for our combat system.
I'm a flight controlman here on Ike. I work on ship's weapon systems. Our job is to defend the ship in case of missile attack. So we have a division of about 20 people, and we work on 4 different systems, but we all work together as a whole to make sure they all run.
I do my part as well as helping out with bringing the fuel up to the deck as well as supervising, so it takes a team effort to get the fuel to the deck.
Well, everything here is a team, so basically to get through the day, you have to eat. You have to be energized, and you can't get energized without the people here on the mess deck cooking your food. Your clothes wash, it's just simple things like that without other people working where they work and making everything here a team.
Of course, media keeps us entertained with movies. I love that. So it kind of brings the outside into the military so we can still feel civil